Hello everyone, today we're going to look at graphs of tangent, cotangent, secant, and cosecant. On your notes you have just blank graphs because I want you guys to pause and take some time to sketch it. And I'm going to be using Desmos. I recommend you use the same because, well, Desmos is awesome. First thing I want you to do is graph both cosecant, which is the first function we'll look at, as well as sine. Now the reason we're graphing both these on the same one is because the reciprocals of each other. If you draw the rainbow reciprocals, you see that yeah, those two are reciprocals, and it's easiest, instead of memorizing and learning what new functions look like, it's easiest if we simply use old functions that we already know, and you're going to see this theme over and over again, okay, during this video. So let's start going. So the first thing I want to point out to you guys, and I'm going to just take away those two things so you already know what they are. First I want you to focus on is this dotted line here, okay? This dotted line is the line over which you flip reciprocals, and let me explain what that means. For example, if I have a value of 1/2 right there on sine, then for cosecant it's going to become 2. Alright, you just reciprocate that value. Whatever the y value is, it flips. Okay, that's the definition of cosecant. If you have 1/3, it's going to flip and become 3. Okay, so we're flipping over that dotted line. We're not flipping perfect mirror. It's a reciprocal function. All right. So anything under that line goes above it, and it's all scaled. So yeah, if you know that, you can go ahead and start plotting some points. The one point that's really important for you to plot on this, or there are a few, but one of the main ones is the value 1, because 1/1 equals 1. So that's where those two graphs touch, because they have the same y value. If you plot that 1 and you also get yeah, a few of these others, then these can be really easy to sketch. This brings up another theme, is that for all these functions it's easiest to plot a few points first and then to start drawing your lines. Okay, it's really hard to draw curves and try to freehand it onto the point you want it to get. The best thing, and the way I will recognize if you've done it right on the quiz, is to plot those points first. Okay, so as we continue to the right, same thing happens. 1/2 becomes 2, and 1/3 becomes 3, and so on. 1/4 becomes 4. I just didn't do all of the points. As you get closer and closer to the right, though, something funny happens right there. Okay, where sine is 0, when you try to reciprocate that, 1 divided by 0 becomes undefined. And that becomes, there isn't a value for cosecant. It actually becomes an asymptote. So and when you're graphing these, yes, you need to fill in the asymptotes, so you'll draw a dotted line there. I'm just going to write an asymptote so you know that. And yeah, going on from there, you just continue with the same thing with the negative side. So -1/2 becomes -2, and -1/3 becomes -3. Alright? Again, we get to the value -1, and -1/1 is, or 1/-1 is still just -1. So that's another place where sine and cosecant hit. So as you see, we just continue on with these, and there are lots of asymptotes here. Okay, I'm gonna kind of move on to the next slide because it got a little messy. Yeah, I want you guys to notice that for the period, it doesn't repeat itself when it does the bottom part. Okay, so the full period of this function is actually 2π again. Alright, which happens to be the same for sine. So again, if you already know sine, which you should, then cosecant becomes really easy as long as you're referencing back to sine. Yeah, the domain and range of this function is also very bizarre. The domain is all x's, because you can plug in anything, except you can't plug in 0 because there's an asymptote there. And in fact, at every asymptote you can't plug it in, which also happens at pi, at 2π, at 3π, 4π, 5π, 6π, and the negatives. So -π, -2π, and so on and so forth. Okay. The range is the very bizarre one. Okay. You notice the blue lines, they go as high as possible on the graph and low as possible, but they never get in the middle area. So if we draw two lines, one at +1 and -1, they do hit those points. See them? So you want to say it like this: y is greater than or equal to 1, or y is less than or equal to -1. Okay, so it's everything above the top line and below the bottom line. That's the domain and range. I'm not going to show you guys how to do secant on this because it is very, very similar to cosecant, and the reciprocal of secant is cosine. So I want you to try the same process I did, plotting the points and reciprocating them, and finding out. Especially important are these places right here and here, where if you just plot those points where the y value equals 1, and you also plot the asymptotes, then you will get all of the idea of the graph, and that's what I really care about. Okay, let's move on to tangent. First thing I want you guys to notice is that tangent is, as you all know, is opposite over adjacent. And if you put sine over cosine, that's opposite over hypotenuse over adjacent over hypotenuse. And if you multiply those fractions out, you actually get opposite over adjacent, which means that tangent is the same as sine divided by cosine. Now, another way to see that, you can see right here, is if we switch back and forth, you see there's sine over cosine, and there is tangent. Okay, see, no difference. All right, so yeah, Desmo said so. No, that's not a rigorous proof, but we will do that when we get to identities in a little bit. But I just want you guys to see that those are actually the same thing. Once you know that, we're going to do the same process as we did with cosecant, where we just define and sketch our tangent in terms of two graphs we already know, that is sine and cosine. All right. So the first point I want you to notice is right here, 0. Okay. You plug in 0, because it's sine over cosine, that's 0, which sine at 0 is 0, and cosine at 0 is 1. It's just equal to 0 over 1, aka 0. So yeah, that first point is 0, 0. A very important starting point for tangent. All right. The next point I want you to notice is when this tangent function goes through the point 1. It goes through it when sine and cosine are equal. So tangent, which happens to be pi over 4, that's you're going to recognize that from the unit circle. You know, when you're drawing your unit circle, it's the easy one because it's where x and y are equal. Well, that's because sine and cosine are both equal to root 2 over 2. So root 2 over 2 over root 2 over 2 equals 1, and that's another point that you should plot when making the tangent function. Okay, I just also want to point out that the same is true on the negative pi over 4. Yeah, except one of the two values is negative, so it becomes -1. All right. The next important point, or non-point rather, is looking at pi over 2. There's an asymptote there, as you can see from the graph, and the reason that asymptote is there is because now cosine is 0. Well, cosine is the denominator, so you get that tangent of pi over 2 equals 1 over 0. But we can't divide by 0, so we say that's undefined. All right. Once you get those features of the graph, the rest of them are just the same repeated pattern over and over, and along with all those asymptotes, and it becomes very easy to graph. So the hardest thing is just getting this started, and you can get that started simply by thinking of tangent as sine over cosine, and thinking about when are sine and cosine 0, and what does that mean in that fraction, and when are they equal, and what does that mean, or one is positive and negative. Yeah, that becomes easy to graph. The period, real quick, is pi, which is different than sine and cosine. You notice that this repeats because once you have gotten from one asymptote to the next, the function just repeats itself. Another interesting feature about this function is always increasing, okay? Because you don't say that when you jump over an asymptote that it decreases or anything like that. It's simply always increasing. So it also gives an interesting domain and range. Domain is all reals except at the asymptotes. And if you look closely, those asymptotes happen at pi over 2, 3 pi over 2, and 5 pi over 2, and 7 pi over 2, and so on. So it's all the odd numbers times pi over 2, which is, yeah, a repetitive feature. It's every pi. The other thing is the range goes from all reals, because you can go as low as possible and as high as possible when you get close to those asymptotes, and there's no middle skipping like there is in cosecant. Alright, so I did this one. I'm going to let you guys do secant and cotangent, and I'd like for you to do those before coming to class. Okay, so here's simply tangent again. So I'm going to write this down. Do cotangent of x and secant of x, neither of which I did, before class. So that way you can share those with your friends and work together and make sure you guys have those plotted correctly. Okay. If you need to, you may also use Desmos to help you in that. However, on the quiz, I expect you guys to be able to graph that by thinking about it and draw the connections between those and sine and cosine. All right. So that's it for this video. The rest of this video is jokes if you want. We have some tan lines here. There's also the terrible pickup line, "Hey girl, what's your sign?" Well, it must be pi over 2 because you are the one. Yeah, that's awful. Just so you know, math puns are the first sign of madness. Just look out for that. Okay, and we're going to end there.